Hi, welcome to the video lecture on critical thinking about statistics. In this lesson, we're going to talk about some of the things that can go wrong during the course of a study. A lot of what you're going to be doing after you leave this course with statistics is you're not going to be generating the analyses yourself always, but a lot of times you're going to be reading about them or hearing about them in the news, journal articles, etc. And so as you approach those studies that you hear about, it's a really good idea to approach those with a healthy skepticism, because you don't want to be taken in by bad statistics. So the first thing we're going to talk about is the source of the study, the source of the research. The first thing to look at is, where's the money coming from? If the Bayer company, for example, is funding research on the benefits of aspirin, that's a conflict of interest. It doesn't necessarily mean that they're going to lie about the results, or fabricate anything, but it might be tempting for them to cherry pick some of the better results, some of the results that suit the narrative they're trying to generate. The best sources for funding are going to be the National Science Foundation, the National Institute for the Humanities or Health. There are a lot of legitimate sources, so that's always something you should ask about. The next thing is, how credible is the publication itself? You should look for a publication that has peer review, meaning that other scholars in the same field have reviewed it and decided that it's worthwhile. Look also at the qualifications of the researchers. You want to see researchers that either work for a university, that they have education, they have experience, and that information is usually available if you look hard enough into the original research. The next thing you should do is what I call the sniff test. And that's just sort of ask yourself, does this sound right? Does something seem fishy about it? I read a study that said, I think 7% of all adults surveyed thought that chocolate milk came from brown cows. That to me doesn't pass the sniff test, because to me, I don't think 7% of all adults really believe that. I think that might be an issue of people weren't taking the survey seriously, but I don't know. So ask yourself, does it seem right? Does it sound right? Is it sensationalistic? If it makes sensationalistic claims, then maybe be a little extra skeptical and ask some more questions. So now let's look at some of the things that can happen with data collection. So a lot of what we're going to do the rest of the course is we're going to assume that the data we've collected is legitimate, and all of our conclusions are going to be based on that assumption. If the data that you've collected has some fundamental problem with it, you're going to have problems with the conclusions as well. So let's look first at sample size. Sample sizes vary a lot from study to study. Sometimes a small sample is the best you can do. I've seen studies based on samples of size 8 or 10, and that doesn't mean it's a bad study. It just means that's the best they could do. When we talk about small samples, we're talking about samples of size 1 or 2. You always look for, is the researcher doing the best they can? All statistics occur in the real world, and there are limitations in the real world. And so you try to do the best you can. And then what do you do if you can't get a big sample size? Well, you just state it in your research, and you say that's a limitation of the study. And so you would hope that if you're reading a study based on a small sample size, that they would say this is a limitation of the study. So let's talk about sampling. So we want the sample to be representative of the population, meaning we want a sample that is basically a smaller version of the population. Sampling bias is when you have a sample that is not representative of the population. If you have a sample that's not representative, then any inferences you want to make are not going to be valid. So the first thing you see this picture, you may have seen this picture before. This is a picture from 1948 from the presidential election, where this is Harry S. Truman holding up a newspaper saying, "Dewey defeats Truman." That's because polls were unanimous. Every single prediction was that Dewey would win. And in fact, Truman won. And there are different thoughts as to why that happened, but one of the most common ones is that at the time, not everybody had a telephone, and so the polling that took place was via telephone, and it tended to be the richer people had telephones and the poor people didn't. And so they ended up, the polls were based on the rich people, who were the ones who were going to vote for Dewey. When election time came around, the poor people voted as well, and it turned the tide for Truman. So that's what happened here. We had sampling bias. So in the samples that were taken, you had the poor people were underrepresented, the rich people were overrepresented, and I'm oversimplifying this, but that's what happened. You did not get a representative sample because not everybody had a telephone. All right, so the next thing let's talk about is convenience sampling. Convenience sampling is exactly what it sounds like. Subjects are chosen because they're convenient. Convenience samples are really not ever going to be representative of the population. So here's a silly example, but suppose we want to know how much money people are spending on Christmas presents this year. So if we go to a local mall, say the South Park Mall, the day after Thanksgiving, and interview people as they pass by the water fountain, that's a convenience sample. By doing that, think about who we are overly sampling and who we are undersampling. We're only getting people who are shopping at that mall on that day. And the question is, are those people different in terms of their buying habits than the people who didn't end up in the sample? And the answer is probably yes. So we're only getting people who shop at this mall as opposed to other malls. Not people who shop online. Not people who shop, at the flea market. You name it. Okay? So, that's sampling bias. The next thing that happens is non-response. Non-response is a huge issue in telephone surveys and mail surveys, where the people are chosen to participate, but they opt out. The people who participate are usually different from those who choose not to participate. So with non-response bias, you've got people who are selected to participate, but who either don't pick up the phone or who hang up on the person when they receive the call. Okay? And it's a stereotype, but usually you get older people participating in these kinds of surveys. And there are things that they can do to try to correct for that, but it's not going to be perfect. So any telephone survey or mail survey or any survey at all is going to have a potential for non-response. And that problem is only getting worse and worse with modern technology. And think about it. You yourself probably have received a call from a pollster, and think about whether you answered the phone or whether you were willing to talk to them if you did answer the phone. And since the response rates are low, usually 10-15% out of the people they sample end up in the sample, you always have to be careful generalizing to the population. Let's talk about voluntary response bias. Voluntary response is not when you sample people but they opt out, but with a voluntary response sample, people opt in. So here's an example. If you work at a restaurant and they have comment cards available on the table, the people who fill out that card, those are a voluntary response sample. And it says here, the manager is surprised most people who respond had an unfavorable opinion of the restaurant. But you've probably seen this. Only people who are motivated will reply to something like that. And usually it's because they've had a bad experience. So sampling bias, again, has an important impact on interpretation of results. What we do is we can really only conclude to the population that we've sampled from. So in the Christmas shopping example, we can't infer to all Christmas shoppers, but instead we infer only to the people who shop at that mall on the day after Thanksgiving, because that was the sample we collected. And in the restaurant example, we can't infer to all customers of the restaurant, but only to the ones who would volunteer to fill out the cards. So you see how you get some pretty steep limitations based on sampling bias. So let's look at some other problems that might occur. In a survey, you might get questions that are worded in a way that's confusing or in a leading way. Here's an example. Are you in favor of euthanasia to stop the suffering for terminally ill patients? The first problem with this question is that not everybody knows the word euthanasia. If they don't know, they won't always ask. They might just say, yeah, sure. So you might need to clarify what euthanasia is. The second thing is, the question is leading. They're basically telling you euthanasia stops the suffering for terminally ill patients. Are you in favor of it? So they're telling you how to answer. If you rephrased it in a way that is not leading and spells out what euthanasia is, you get a better answer. If questions are worded in a way that is bad enough, then you might get completely worthless results. That's one of those times when you really can't try to get anything out of it. Let's look next at motivation to lie. So surveys sometimes are based on or trying to get information about something that's very sensitive, like income or illegal behavior. In this example, I heard about this one time. I don't know if it's true, but I heard that homeroom teachers were told to ask their students, their middle school students, for a show of hands for who had ever tried marijuana. That's motivation to lie. So they don't want to admit to their teachers if they've tried marijuana. On the other hand, they might want to brag in front of their friends even if they haven't. So it's hard to tell which way that would go. So motivation to lie is pretty easily fixed. You just ask the questions anonymously. Let's talk about basis for comparison. Standalone statistics are a problem. And I'll give an example before we look at the one on the PowerPoint. Last week I saw something talking about complaining about how much money the president has spent so far on golfing trips. And, you know, they gave the amount and they said that's a tremendous amount. And the thing is, that might be. But unless you compare it to something else, unless you compare it to previous presidents, other recent presidents, compared to something else, we don't know if that's a lot or if it's not a lot. So without that basis for comparison, you know, we don't have any context for it. So here's the example that I did read one time. 68% of all teens who commit suicide come from a broken home. So they don't live with both of their parents. This sounds like a high percentage. And it might give the impression that having parents who are divorced would lead teens to commit suicide. However, it's also true that almost exactly the same percentage of all teens come from broken homes. In other words, they don't live with both of their parents. So what that tells us is that teens who commit suicide, in terms of whether they live with both of their parents or not, they're the same as other teens. So that first statistic alone, that 68%, is correct, but it can be misleading. Next thing, operationalizing variables. A lot of times, especially in the social sciences, researchers want to look at something that's not obvious in the way you measure it. If you're looking at distance or time, those things it's obvious how to measure them. But if you're looking at a variable like intelligence, consumer satisfaction, student learning, you have to figure out how to measure it. And usually there are scales for those variables that are developed over time. But you always want to ask. I've seen where sometimes a student's SAT score or GPA is used as a measure of intelligence. That's probably not a good way to measure intelligence. So ask yourself when you read a study, how is the variable operationalized? You can kind of use your own judgment on that. You know that GPA is not a good way to measure intelligence. Look for a measure that has been developed by somebody with qualifications and used in other studies over time. Next, let's talk about an issue related to the interpretation of results. And this is an issue that comes up all the time. Correlation versus causation. If you learn nothing else in this course, learn the difference between correlation and causation. Correlation is when you have two things that tend to occur at the same time. Just because two things tend to occur at the same time doesn't necessarily mean cause and effect relationship. And we always say correlation does not imply causation. So here's an example. And this is kind of a ridiculous one, but it's true. People who take medication for high cholesterol do tend to have more heart attacks than the general population. So someone might reach the conclusion that taking medication for high cholesterol would cause heart attacks. That's a cause and effect conclusion based on this correlation. Well, the problem there is, obviously, if you're taking medication for high cholesterol, then you're going to be at higher risk for heart attack because you've got high cholesterol. So you can't conclude that cause and effect. Here's another example, and this I've heard to be a true statistic. Couples who live together before marriage tend to get divorced more often than other couples. And it might be a natural, you might be tempted to reach the conclusion that living together would cause couples to be unhappy together and then more likely to be divorced. In this case, cause and effect can't be determined here either. In this case, you've got another variable, and that's the attitudes and values variable. So whatever made a couple live together in the first place might also make them more likely to get divorced later on. In this case, that third variable that potentially is causing the other two, it's called a confounding variable or a lurking variable. And it might be what's causing both of them. The thing is, we can't tell. We can't tell because it's correlated with this third variable, this confounding variable. So there's only one case when cause and effect can be proven, and that's when you have an experiment and not an observational study. Okay? So an experiment means random assignment. When the researcher assigns the treatments to the subjects and observes the reaction. If you've got random assignment, then we can conclude cause and effect. If you don't have random assignment, you cannot conclude cause and effect. So in the example with the couples who live together, that's an observational study because the researcher was not able to do random assignment and say, these 20 couples are going to live together before they get married. These other 20 couples are not. We'll randomly assign them whether they're going to live together or not before they get married. And then after 10 years, we'll observe the divorce rates. Okay? If we had a study like that, then we could determine cause and effect. But the researcher could not make that decision for people. Therefore, that one, we can't determine cause and effect. Okay? All right, so in conclusion, always be skeptical. When you read a study, ask questions. Read further. Look at the original data. And then if anything seems wrong, don't necessarily throw it out, but maybe pay a little bit less attention to it. All right, that's it for this lesson.